In this section, we're going to talk about different graphs of some equations. First concept to cover is what an x-intercept and what a y-intercept is. Well, in this graph of this green line, this point right here is the x-intercept. Now, at that point, we have an x-coordinate, but the y-coordinate is equal to 0. Similarly, let's see, what color do we want to use? How about blue? This point right here, this is the y-intercept. This is an x-coordinate of 0, but some y-coordinate. So that informs how we find an x-intercept and a y-intercept. To find an x-intercept, all we do is set y equal to 0. And similarly for a y-intercept, to find that we set x equal to 0. So let's look at this example. Find the x and y-intercept for the equation y equals x squared minus x minus 2. So for the x-intercept, what we want to do is set y equal to 0. So we're going to say 0 is equal to x squared minus x minus 2. So we need to solve for x. This is a quadratic. We can solve this simple quadratic by factoring. We're going to have x minus 2, x plus 1. And then we just set each of those equal to 0 and solve. So x is equal to 2, and x is equal to negative 1. So the x-intercepts, we'd like to write the x-intercepts as coordinates. So this first x-intercept will be 2, 0. The second will be negative 1, 0. For this particular equation, finding the y-intercept is no problem. We're going to set x equal to 0. So y equals 0 squared minus 0 minus 2. We end up with y equal to negative 2. So the y-intercept, again, let's write this as a coordinate, and we would have a y-intercept of 0, negative 2. Now you probably recall what this type of graph looks like. It's a parabola. So we can graph the parabola. Well, I have a point at 0, negative 2 down here, and then I have 2, 0, and negative 1, 0. So it's going to look something like that. We could get a little more precise, but with just the intercepts, that's about as good as we can do. Next up, let's talk about the symmetry of a graph. A graph could have 3 different types of symmetry. It could be symmetrical about the y-axis, about the x-axis, or about the origin. Or a graph could have no symmetry. So this would be an example. Imagine that parabola is perfectly centered around the y-axis. This would be an example of a graph that has symmetry about the y-axis. Here's an example of a graph symmetrical about the x-axis. And then if we're talking about symmetry about the origin, well, the origin, what we mean by that is the line y equals x. So oftentimes a graph that is odd, looking something like that, that would be an example of a graph that is symmetrical about the origin. So we want to be able to look at an equation and quickly determine whether there is any symmetry, and if there is symmetry, what type of symmetry it has. So there's a test for each of these. For y-axis symmetry, for a graph to have y-axis symmetry, every point, xy, that's on the graph, negative xy is also on the graph. So to test this, what we do is we replace x with negative x in the equation. And if after simplified, those equations are equal, then we have y-axis symmetry. So imagine we have this point right here. Let's say that point is, I don't know, 5, 1. If this graph were to have y-axis symmetry, well, this point would be negative 5, positive 1. See, we have a point xy, the negative xy is also on that graph. So that example illustrates this point. So conversely, for x-axis symmetry, any point on the graph, x negative y must also be on the graph. So to test, we do it in a similar fashion as before. We want to see if we replace all the y's with negative y, and the equation holds or is equal, then we have x-axis symmetry. Lastly, for a graph to have symmetry about the origin, what we do is we need to see that if x and y are both replaced with their opposites, so negative x and negative y, and if that is also on the graph, then we have symmetry about the origin. So to test, we replace both the x and the y coordinate with negative x and negative y, and if it's still equal, we say that the equation has origin or symmetry about the origin. So for this example, which says determine whether the graph of the equation y equals 1 over x squared plus 5 is symmetrical about the y-axis, what we do, because there's y-axis symmetry, what we want to do is we substitute negative x for x. And if after doing so and simplifying down, if we still have the same equation, then we would say that there is symmetry about the y-axis. So let's do that. Y equals 1 over, in place of x, I'm going to substitute negative x squared plus 5. Well, y equals 1 over negative x times negative x is positive x plus 5. So that is equal to what we started with. So we would say yes, symmetry about the y-axis. And moving on, the last thing in this section deals with the equation of a circle. So let's see how this works. So suppose we have a circle and we have a center in the circle of hk, and we have a point on the circle, xy, and then r is the radius of the circle. Now what we want to do is come up with an equation that'll get us every single point on the circle. Now the radius here is really just a distance between these 2 points, hk and xy. So if I wanted to figure out this distance, r, I'm just going to use the distance formula. So I do the difference of the x values, so x minus h squared, plus the difference of the y values, y minus k squared. And then typically how we write this equation is we square both sides. So r squared equals x minus h squared plus y minus k squared. And that is the general or the standard form for the equation of a circle. And that circle has a center at hk and a radius equal to r. So we'll wrap up this video with a couple examples. Find the standard form of the equation with a center 7, negative 3, and passes through the point 5, negative 2. Well, 7 and negative 3, 7 is the h value, negative 3 is going to be the k value. Now remember, the formula is x minus, oops, we don't want that square root in there. This would be the equation we're going to deal with. So we need to figure out the r value, or the radius, and then the center. Well, we have the center, so we're going to say x minus the h value, which is 7, squared, plus y minus the k value. Well, k is negative 3, so we're going to say y minus negative 3 squared. That is going to equal r squared. So simplifying this part down, we get r squared equals x minus 7 squared plus y plus 3 squared. Now to write the equation, we need to figure out what the r value is. So the r value, to do this, we just substitute in this point for x and y and solve for r. So r squared equals, we're going to plug in 5 for x, so 5 minus 7 squared plus negative 2 plus 3 squared. Simplifying this down, we get an r squared value of 5. Now, in the standard form of the equation, we actually use that r squared value. So we're going to put 5 in right there. So we'd have 5 equals x minus 7 squared plus y plus 3 squared. And that would be the equation of the circle. If the question asked what the radius is, well, down here we have the radius squared is equal to 5. So the radius is the square root of 5. last example says, find the center and radius of the circle with the equation x squared plus y squared minus 6x plus 8y plus 10 equals 0. So what we need to do here is we need to get this given equation into the standard form, because once we know what the standard form of the equation is, h and k represents the center and r is the radius. Now we're not quite at this point, so we have a little bit of work to do to get it into the standard form. So what we're going to do is we're going to complete the square for both x and y. So to do this, group the x terms together and then leave a space. Group the y terms together, put the constant on the other side of the equal sign. So to complete the square, what we do is we take this coefficient right here, we say, what's half of negative 6? And then square that value. So half of negative 6 is negative 3, negative 3 squared. So we'll say negative 3 squared. I'm going to add negative 3 squared over here. Then to complete the square for the y terms, I take half of 8. Half of 8 is 4. 4 squared is what I write here. And I also need to write it on the right-hand side, because if I add 4 squared to the left-hand side of the equal sign, to keep the equation balanced, I must do it also to the right-hand side. So what we have on the left, the whole reason we complete the square is so that we can factor this. We get x squared minus 6x plus 9 plus y squared plus 8y plus 16. So these first three terms, I can factor that as x minus 3, x minus 3. For the next three terms, I could say y plus 4, y plus 4. On the right-hand side, I kind of forgot about it, negative 10 plus 9 plus 16. Negative 10 plus 9 is negative 1 plus 16, I get 15 over here. So what we see is that these two binomials are the exact same. Likewise, these two binomials are the exact same. So what we do is we write this as x minus 3 squared plus y plus 4 squared equals 15, like this. So we have the equation now in standard form. So once we're in standard form, we know what the center is. The center is hk. So the center is going to be positive 3, negative 4, and the radius is going to be, well, this is really equal to r squared here. So we don't want to know what r squared is. We want to know what r is. So r is equal to square root of 15. So the radius here is square root of 15, and this is the center, 3, negative 4. So kind of one of the main things to be careful of in this question is whatever this value is right here, that negative 3 and then the 4, whatever those values are, when we convert that into hk, it's as though we take the opposite value. So while in that factor, x minus 3, it looks like we have a negative 3, we want to make that a positive 3 when we write that as the center. Likewise, here in this factor, we have y plus 4, but we want to change that to negative 4 when we write that as the center coordinate.